Hello, my name is Brena, and typically my teaching style, my instructional style, involves a lot of question and answer and a lot of feeling the room. So figuring out what people already know and what I can elaborate on. So doing a tutorial, I can't really do that. What I am assuming is that you know that the area of a circle is pi r squared, where r is the radius of that circle. And you know a little bit about taking antiderivatives. So you've done some calculus, you know how to take a derivative, and you know how to work backwards. And you also know the equation for a circle. And maybe you've wondered where the volume of a sphere formula comes from. I know I did when I first had to memorize it. What is this? Yeah. All right, so let's get started. I'm going to make a pretty generic circle, and for the purposes of being able to slap some calculus on it, I'm going to position it in the coordinate plane. Cool. I draw a really good circle, don't I? All right, so for simplicity's sake, I'm only really going to think about the top half, the positive half, the half that has positive y values, because it's symmetric. It's got positive and negative x values for any pair of points. It's got positive and negative y values. So I'm not going to erase this bottom half, though. Okay, cool. All right, and I'm going to keep this circle very generic. I'm going to let its radius be r, some constant r. So the equation of this circle, centered at the origin, is just x squared plus y squared equals r squared. I keep a million pencils and pens, and I just dropped one. Okay, I'm going to rearrange this. I don't really like having it implicit, meaning the x's and y's are jumbled together on one side of the equation. So I'm going to get y alone. And I'm only really interested in the positive half of the circle. So I'm only going to keep the positive square root. And if I just say square root, I mean the positive square root. If I stick the plus or minus, I'm including the entire circle, but I'm not a function anymore. Oops. So I'm only interested in the top piece. The reason is it's going to work. Haha. All right, so I'm going to take that piece, that half of a circle, and I'm going to stick it on a string. I'm going to let the x-axis be a string, and I'm going to twirl that string. So I'm rotating that semicircle around the x-axis. And if I do that really, really fast, I see a sphere. We're going to find the volume of that sphere. So if I imagine taking that sphere and taking a machete and slicing perpendicular to the x-axis, so I'm going boop, 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 then I'm doing an integral with respect to x. Dx. Cool. My x values are going from negative r all the way up to positive r. And the area of each slice, when I'm going boop, 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 the area of each slice, well, each slice looks like a circle. So if I imagine this slice right here, and I've rotated this semicircle, I imagine that slice right there, and I pick it up and I look at it, it's a circle. And the radius of that circle, the circle in question, is the y value where I took my slice. So the area of that circle is pi y squared. And I can take that pi and stick it out here. And I can replace y with an expression that is equivalent to y, but involves x and a constant. R is a constant in this situation. Cool. And I love seeing the square root of a positive thing getting squared. That's cool. Because it goes away. Ha-ha. All right. Now, that pi is still going to chill for a while. And I'm going to take the antiderivative. So r squared is a constant. So the antiderivative with respect to x is r squared x. That negative chills. And x squared, the antiderivative of that, is x cubed over 3. And I like mentioning who I'm replacing with the bounds. Because I mentioned it right here when I said dx. Sometimes people just put the bounds and they don't put who is getting plugged in. I just like mentioning who's the variable. Cool. All right, evaluate at upper bound. And I'm using parentheses when I do substitution. It's just a good habit, y'all. So there's upper bound. Subtract it, evaluate it at the lower bound. Cool. And why don't we have to write plus c when we're evaluating bounded integrals? Because it cancels. Cool. Okay. All right. This is r cubed. This is also r cubed. This is a whole r cubed minus r cubed over 3. So that's 2/3 r cubed minus. All right. This stuff, here's a negative r cubed plus, because this negative r getting cubed, negative r times negative r times negative r, that's still negative r cubed. So those negatives cancel. Negative r cubed plus a third r cubed, that's negative 2/3 r cubed. Cool. 2/3 of this thing, 2/3 of stuff, minus a negative 2/3 of the same stuff, that's just 4/3 stuff. And I'm gonna pull that 4/3 out front. There's my pi, there's my r cubed, and that looks annoyingly familiar. Ta-da!